All right, hello everybody. Today I'm gonna show you the first couple prompts with an agent where I attempt to have the agent port a program that was written by the agent, Claude, in TypeScript, from TypeScript to Zig. I've already done this exercise once. I'll show you this program first. I call this program my Safari screensaver. It's taking a little longer to warm up than it normally does. But all this is it's like a little first person driving game. Um, and this is running Zig WebAssembly. You're supposedly on a motorcycle here. I originally had it using a car, but then I decided a motorcycle can turn more effectively. And when you come up to a corner here, you'll see that the motorcycle actually kind of leans into the turn, and all this 3D math is happening in Zig now. It used to happen in TypeScript, and the agent and I originally wrote this program in TypeScript, and I had it ported to Zig. And now I have another program here that is still in TypeScript. This program here is implementing the Clark-Wright modification of the Clark-Wright algorithm in TypeScript. The basic problem here is that you've got a bunch of houses that need deliveries from a trucks that are from a warehouse. You only have 8 trucks. Each of the trucks, most of the trucks, I think we have 6 trucks that have capacity of, yeah, 5 trucks with the capacity of 14 totes, and then we have 3 smaller trucks that only have 12 totes. And the algorithm tries to divvy up all the houses. And you can see here that the houses are pretty well clustered. Like the person driving the purple truck, which I guess is truck 4, um, is doing a fairly logical route. They go from the warehouse in Bellevue, fictionalized Bellevue, out to fictionalized Green Lake in the Seattle area, hit the U District on the way back, or probably on the way out, actually, and also Medina on the way out. In fact, if I hit space, you can see the trucks, and you can see this purple truck is already making the deliveries. Anyway, I want to port this to Zig, so I go to Claude and I say hello. I want to start a new project where we port the Seattle delivery app from TypeScript to Zig. Claude understands basic acronyms like TS. We have done this before, of course. Safari game. Maybe a good way to start is by telling me how much TS code already exists, just to get some idea of the scope. And did we have tests of any sort that can be either reused directly or ported? So while this is thinking, when we originally did this app, we started off with a very basic version of Clark Wright, and the agent coded up something, similar to the quote unquote final version that you see here, pretty quickly. But the routes would have weird things. Like you can see here how well clustered the routes are. Like the green houses are all together, the orange houses are all together, this shade of blue is all together, this other shade of blue all together, with this one like little lone house. Sometimes the routes aren't as clean as you'd like them to be because unfortunately truck 4 just did not have enough capacity to grab that one house. So the blue truck 6 probably came out of the warehouse, went up to fictionalized Redmond, over to fictionalized Kirkland, and then hit that one house in Medina on the way back. Anyway, let's see what the agent's doing. The agent says I've got the inventory. Let me confirm the next free essay number and check how the harness's gold file is wired, then write this up. Everything I need, right in the scope. So I've set up a essay surface with the agent so that when the agent has to scope out fairly complicated things, the agent literally just writes a file to my file system. In fact, I can probably show you that. Yeah, all of these quote unquote random um, .md files are essays that the agent wrote, and you can see that it's now writing random 804. And it actually gives me a digest. Half the time I can actually just read the digest. It's gotten way better about writing digests. I don't think that's due to me writing better memory instructions for it. But here I'm looking at the essay surface. It's served up on port 9100 from my WSL instance, which is just running a real simple Golang server, Go, um, the Go programming language. Anyway, so it says the scope in lines and oracles. We have 4,500 lines of TS. And the part that wants to be Zig is only 2,150 lines of pure logic. I can almost guarantee that I'll get this done in a day. The 2,000 lines is like easy pickings for an agent these days. So let's see. Everything lives in Safari precedent. Okay, the Safari precedent. Remember I showed you the Safari program. Let me go back to that. Again, this was the program that we already ported. I call it the Safari screensaver. And by the way, while this is running in the web, this is actually my screensaver too. And the screensaver is using the same 90% same Zig code, but writing to a different target to make an actual Windows screensaver. But what you're seeing here is in the browser. I'm in the Firefox browser. I'm in Firefox. And it's running WebAssembly. And Zig allows you to compile to that target. So back to the essay. Here's a cat coming across the road. Back to the essay. The Safari's port shape was Zig to WASM computes, tiny JS blitter draws. Delivery follows the same theme. We have some clearly Zig stuff. So the solver.ts is the algorithm that figures out how to divvy up the totes among trucks. Okay, so I have a judgment call here. The judgment call map view. Safari answer this with a drop command protocol. The same answer works here, but it's the bulk of the tedious porting. An honest alternative for phase one, leave map view and main in JS, swap the solver's brain. Okay, and that makes perfect sense. It's like I want the solver to potentially be faster by porting it to Zig. Even if it's not faster, it's a good exercise to learn agents to try porting things to other languages, especially a relatively obscure language like Zig. Stays JS regardless. Test what exists. There is no test work and there are no unit tests. What exists is better sorted to a port. We've got real assertions in the solver. Okay. Okay. So it's suggesting you use the benchmark pattern here. Okay, let me go straight to the vertex code for comparable to Safari, maybe a notch bigger on logic and a notch smaller on risk. 2150 lines of pure logic to port mechanically, 1,000 line drawing file with a known seam pattern if we want it. Ready-made legality check and a determinism guarantee that hands us a bit exact cross-language oracle for free. Scariest file is solver.ts and it's scary only in size. It's the best document, most tested code in the directory. Open choices. When you're ready, full Safari treatment versus solver brain first. And whether the gold corpus is 20 seeds. Let's focus. Very solid gold corpus. 20 shuffles, or what is 20 seeds. And then we will proceed to porting just the solver. Saying ideally during the earliest stages of development, we won't even need me to look at the browser. So just compile command line testing is kind of hand wavy, but I can almost guarantee you that Claude understands what I mean by that. And what do I mean by that? I mean that I want Claude to just compile like a very simple program that runs the that for each of the 20 seeds runs the algorithm in Zig and then compares the algorithm to what the current TypeScript code produces. So you can see it's saying gold corpus first, then let me read the solver's output shape to decide exactly what the gold file pins, especially where floats might sneak in. So it's thinking, and I think I will end the video here and then create a new video soon afterwards. I haven't been recording YouTube videos very frequently or very recently, so I want to make sure that I can actually go through this process before I keep on talking. But anyway, you can see that it's thinking here, and basically with 2 prompts, I've already got the agent up and running and starting to write code. Okay, I'm going to end it there. Thanks for watching.